In this theorem, we're going to add up the first n square counting numbers. That is the summation of I squared as I goes from 1 to n. The first I is 1 and I square it, then I is 2 and I square it, and I do this all the way up to n and I square it. And this is n times n plus 1 times 2n plus 1 all over 6. So we want to prove this fact, or theorem, a proof by induction. If n is 1, then this is just 1 squared or 1. And does it equal to the other side when n is 1? It's n times n plus 1 times 2 times n plus 1 over 6. Well, this is 1 times 2. 2 plus 1 is 3. 1 times 2 times 3 is 6. Divided by 6 is 1. So, yep, this is correct. Now we make our assumption. We assume for n equal to k that 1 squared plus 2 squared all the way up to k squared is k. Instead of n, I'm going to write k. I'll even say n times n plus 1 times 2n plus 1 all over 6. Now, what we want to do is show for n equal the next value, k plus 1, that 1 squared plus 2 squared all the way up to k plus 1 squared is equal to, instead of k, I'm going to say k plus 1. K plus 1 plus 1 is k plus 2. 2k is going to be 2 times k plus 1 plus another 1. Well, that's going to be 2k plus 2 plus 1 more. It's going to be 2k plus 3. 2k plus 3 all over 6. So this is what we want to show. So 1 squared plus 2 squared all the way up to k squared plus k plus 1 squared. That's what we want to figure out. But we know what this equals. Or at least we're assuming it. It equals to this. K times k plus 1 times 2k plus 1 all over 2. Sorry, all over 6. And we want to add k plus 1 squared. Me, I like to factor. I am going to factor out k plus 1. So I have what I factored out times everything else. K times 2k plus 1 over 6 plus another k plus 1. So now let us get common denominators. Let's multiply by 6 over 6, which is actually good because I want to factor out a 6 in the end. I want a 6 in the end. Let me actually factor it out. So here I have k times 2k plus 1 plus 6k plus 6. Alright, let us combine, let's distribute. You have 2k squared plus k plus another 6k plus 6. Let's combine those like terms. You have k plus 1 over 6 times 2k squared plus 7k plus 6. Assuming you, so let's see. Right now, we have this part. There it is. But take a wild guess what this is going to factor out to. The answer is going to factor out to that. It has to, unless we made an error somewhere. So we have k plus 1 over 6, but let's actually figure this out. So you're going to have 2k plus a number times k plus a number. And the product should multiply out to 6. So I'm going to put a 2 here and this 3 here. There's a 2k squared. And the middle term is going to work. There's 4k plus 3k is 7k. And definitely the 6 works. Okay. So now I have k plus 1 times, I'm going to say this next, k plus 2 times 2k plus 3 all over the 6. And cross my fingers that this here is exactly what we wanted to show. And it is. Okay, it's exactly what we wanted to show. So, proof is done.